Yes, students, let us start new chapter, that is P block elements. Okay, P block elements come under inorganic chemistry. So we are starting inorganic chemistry. Okay, so what are the group that we have to study is 13, then 14, 15, 16, 17. These are the groups that come under P block elements. 13 and 14 you have studied in class 11th. So we are concerned with the other groups, that is 15, 16, 17, 18. Okay. Now we will start with, that is group 15. Okay. So it's also called as nitrogen family. So the elements will start with nitrogen, then phosphorus, then arsenic, then antimony, and last element is bismuth. Okay, bismuth. So just let us study the general characteristics of these elements. It is a non-metal, nitrogen. Then phosphorus also is a non-metal. Then comes arsenic, which is metalloid. In short form I am writing. Antimony is also metalloid. And bismuth is a poor metal. Okay. Nitrogen is formed in the form of N2, phosphorus as P4. Now the other characteristic properties, mainly at first we will see what is the trend of atomic size in the period, in the group. So you know that as we go down, the atomic size increases due to the number of cells increases, and the screening effect also increases, and therefore the atomic size will increase. So atomic size will increase. Now what happens to the electronegativity and ionization energy? Ionization energy and electronegativity, both they depend on the atomic size, and we can say that both are inversely proportional to atomic size. Okay. So what will happen as we go from top to bottom, that is from nitrogen to bismuth, the elements one by one, what you see that the ionization energy and electronegativity both, it decreases down the group. Okay. So we have seen that ionization energy and this electronegativity, both it decreases down the group. So what are the elements? Nitrogen, phosphorus, then arsenic, then antimony, and bismuth. Okay. So other properties like density, as mass increases down the group, the density will also increases. Then melting point, boiling point, both it increases. Okay. But you'll see some different trend in the melting point and boiling point. First increases from nitrogen to arsenic, then it decreases. So some exceptions you always see in the trend, and that exception is always important. Okay, for give reason. In this chapter you will get the questions like give reasons and structure. Okay, so wherever there is exception, you please note, and it's always asked. Due to the why? Due to the same size of antimony and bismuth. Antimony and bismuth, they have almost same size. Okay, and you know that the electrons, they go to the D and F block, F shells. Okay, and this lead to the contraction. We will study this in the D block elements, and this contraction is known as lanthanoid contraction. Okay, then what about the bond strength? Bond strength. So generally they form the single bond, and the single bond strength, it decreases down the group. Then nitrogen is exception. Its bond is very strong. You know why? Because nitrogen, again the give reason, nitrogen has small size. Then the due to the single bond nitrogen nitrogen, there is repulsion. Due to the presence of lone pair in the nitrogen, what you see that there is repulsion between the bond, and the bond in the nitrogen is weak, not strong, sorry, it is weak. Okay, so question is there in this give reason. So what is the question? That nitrogen nitrogen bond is weaker than phosphorus bond. Okay, pp bond. Okay, so question is nitrogen nitrogen bond is weaker than pp bond. Give reason why. So the first reason is that nitrogen has small size. Then second reason is that when it is the nitrogen nitrogen bond has lone pair. Okay, which repel each other. So this is the second point. And due to the this repulsion, that is inter electronic repulsion, the nitrogen nitrogen bond is weaker. You can say due to inter electronic repulsion. The bond is weaker. I hope you have understood this. Then let's move to the next, allotropy. All elements show allotropy except bismuth and nitrogen. It does not show allotropy. Okay. Then bond formation. Which type of bond is there? You know that N does not have d orbital, so it will form p pi bond nitrogen due to small size and absence of d orbital. Whereas other elements, they can form p pi d pi or d pi bond. Okay. Then next is chemical properties. We will start with chemical properties. So first we will see oxidation state. Oxidation state. So mainly you find the oxidation states is plus 3, plus 5 or minus 3. Okay. So the oxidation state, it increases down the group when you go from top to bottom, that is, you know the elements nitrogen, phosphorus, arsenic, antimony and bismuth. Okay. So the oxidation state increases down the group and the stability of the plus 5 oxidation, it decreases down the group. Down the group. Down the group. And bismuth you find only plus 3 oxidation state. Then minus 3, the tendency, it decreases down the group. Down the group. So why? Because there is increase in size and metallic character increases. That's why. So due to increase in size, then metallic character increases. And nitrogen, what are the oxidation? Nitrogen can be in the oxidation state of plus 1, plus 2, plus 4, and phosphorus plus 1 and plus 4. So these are the oxidation states of nitrogen, and we will study further also. So phosphorus has the intermediate oxidation state from minus 3 to plus 5 in acid and basic medium. Okay. So that is, you can say it show disproportionation reaction. For example, 2S3PO3, it gives S3PO4 and pH3. So one gets oxidized, the other reduces. This is in minus 3 state, this is in plus 5 state. You find out the oxidation state in S3PO3. Okay. Now one give reason question. Nitrogen exhibits, plus 5 also it exhibits, that is N2O5, है ना? But it does not form pentahalide, does not form pentahalide, that is NCl5. Why? Main reason is that it does not have d orbitals absent, or you can say that it only have p orbitals. Okay. Then what will happen? So it can, therefore it cannot expand its covalence. Its covalence will always be equal to what? Plus covalency will always be equal to 4. Therefore it does not form. Then one more question. pH3 has higher boiling point than NH3. Why? Higher boiling point. So the simple reason is there, that the hydrogen which is attached to the nitrogen is through hydrogen bond. means the molecules they means in the ammonia molecule the hydrogen bonding is there between the molecules, that's the intermolecular hydrogen bonding, whereas in this PS3 there is no hydrogen bonding, that is the reason. Okay, now reaction with hydrogen. So what it will form? Hydrides. It will form what? Hydrides. So the elements N, P, As, Sb, bismuth, these are the elements. So nitrogen can form hydrides N3 minus, this phosphorus P3 minus, As3 3 minus, Sb 3 minus, and bismuth 3 minus. Okay, so that is NH3, PH3, ASH3, then SbH3 and BiH3. So these are the hydrides that is formed by nitrogen family. So I think you have understood this. You are noting down in the notes copy, isn't it? Okay. Now come to reaction with oxygen. Reaction with oxygen. So what it will form? Oxides. So it can form oxides X2O3 and X2O5. Okay. Whereas nitrogen can form many oxides N2O, NO, N2O3, N2O3, then NO2, N2O4, N2O5. So the common oxidation states what you have seen, it is +3 and +5, but nitrogen can form many oxides. Then phosphorus. Phosphorus can form P2O3 and P2O5 only. Then arsenic, it can form As2O3 and As2O5. Now about bismuth and antimony. It can form Sb2O3 and Sb2O5, but it is not stable. Sorry, bismuth oxide. So they react with halides and form BiOX and SbOX. What we will call it as oxohalides. Okay, oxohalides. Now come to the topic, reaction with halides. Reaction with halides. Not reaction with halides, sorry. Reaction with halogen, you have understood, I think. Reacts with, so with halogens like Cl, Br and iodine, it can form two types, AX3 and AX5. So nitrogen will form NX3, phosphorus PX3, arsenic ASX3, SbX3. Then nitrogen will not form And X5, I have told you this, the reasons also I have told you. Then PCl5, then ASX5, SBX5. Okay. Then SB and BI. So as we have seen that it only forms the oxo halides it will form, है ना? Why? Because the other halides that form, other elements that form the halides, it is unstable, so it reacts with halogen and form the oxo halides. So the X is in this form. Now next is reaction with metals. Next property. So we have seen that the covalency of the nitrogen is only 4. So it cannot make more than four bonds. Okay. So a nitrogen will form nitrides only. Phosphorus will form with calcium Ca3P2. Arsenic will form Ca3As2. Then antimony forms zinc like this and Ca3Bi2. And each will react with water. So phosphorus will form PH3. This will also form, AsH3. Then this will form what? SbH3. And this will form BiH3. So on reaction with water, this all form, uh, I missed nitrogen also, no? Ca3 and 2 it will exist, and with water it will form what? NH3. So all the elements they form hydrides. Okay. Now next